The ocean covers most of our planet, yet we've mapped more of the moon than these waters. Up here at the surface, everything feels normal. Sunlight, colors, the kind of life we understand. But the moment you start sinking, the rules begin to shift. Down in the depths, some animals don't just hide in the darkness, they erase themselves. They turn transparent, bodies fading until they're more like drifting outlines than flesh. Which brings up a really strange question. Why would evolution create transparency in a place with almost no light, where almost nothing can even see you? At the surface, the ocean feels familiar. There's light, color, and detail, everything our eyes and brains expect to see. But light doesn't travel well through seawater, and the deeper you go, the more it fades. Below a few dozen meters, the warm colors disappear first. Reds, oranges, yellows. One after another, they're absorbed. By around 200 meters, blue is the only color strong enough to survive the journey down. With just that faint blue glow filtering from above, the ocean shifts into a monochrome environment. It's no longer a place defined by patterns or markings, it is a place defined by contrast. Down here, animals don't see bodies the way we do. They see outlines, dark shapes against a dim background, and in an environment where visibility is so limited, creating even a small shadow can be risky. This is where camouflage in the traditional sense stops being effective. The rules of survival start changing, and the adaptations we see from this point on are shaped by what little light the ocean allows. As we move deeper, the water takes on a different personality. The light above isn't gone yet, but it's faint and scattered, barely strong enough to outline anything. This is the twilight zone, where vision is less about color and more about contrast. Animals search for shapes rather than details. Many predators point their eyes upward, waiting for silhouettes to break that dim blue glow. Their eyes are tubular, almost like built-in telescopes, tuned specifically for detecting outlines rather than patterns. In this dim world, bodies become suggestions. Creatures pass as faint shadows drifting through the darkness, and survival depends on not drawing attention to your shape. Transparency becomes more than a quirk. It becomes a strategy. When tissue lets light pass straight through, the body doesn't cast much of a silhouette. Predators looking upward can't easily pick out a shape against that faint blue glow. Even simple forms of transparency start to matter. Small amphipods and early-stage larvae drift almost unnoticed, because there's just not enough of them for light to cling to. Some creatures don't need to be perfectly invisible. They just need to be transparent enough to blur their outline. And in a place where vision depends entirely on silhouettes, even partial transparency can shift the odds of survival. As we sink past the twilight zone, even that faint blue light begins to fade. Eventually, there's nothing left of sunlight at all. This is the midnight zone. Here, vision doesn't work the way it did above. There's no background glow to outline bodies, no silhouettes to hunt by, no color to see. So evolution changes direction. Instead of waiting for light, predators make their own. Small flashes, slow pulses, narrow beams, bioluminescence used not to glow beautifully, but to search for life in total darkness. Dragonfish, viperfish, and other hunters in this region sweep the water with tiny bursts of light, hoping to catch even the slightest reflection off potential prey. And suddenly, the challenge for survival isn't just about hiding in darkness. It's about avoiding detection from these active light probes. Transparency continues to matter here, but it isn't the same simple version we saw above. It begins evolving into something more refined, something that helps animals stay unseen even when predators shine light right into the void. Here, transparency has to deal with something new. Not sunlight, but light that comes from the predators themselves. Many species have tissues that barely reflect light at all, so when a predator sweeps the darkness with a quick flash, nothing bounces back. The scan simply passes through them, and they remain almost impossible to notice. Some animals take it even further. They shift or shield their internal organs, so those organs don't glow visibly when light hits them. Others store digested material in darkened sacs, so the chemical light from their food doesn't leak through their bodies. Every little detail becomes part of the camouflage, not through pigments or patterns, but through making sure that light has nothing to cling to. And as transparency keeps adapting to these pressure points, the creatures that evolve it start to look less like animals we know, and more like forms that the ocean itself has sculpted for invisibility. In the mid-depths, transparency takes on familiar but unusual forms. One of the clearest examples is the glass squid. Most of its body is nearly invisible, with only its digestive gland faintly showing. It combines partial transparency with a soft glow from underneath, a trick called counter-illumination, which helps erase whatever silhouette might remain. Then there are the comb jellies. Their bodies are so transparent that they look almost like lenses floating through the water. When they move, the tiny cilia along their sides refract any available light into shifting rainbow lines. It's transparency mixed with subtle signaling, not to attract predators but simply as a side effect of their structure. And drifting quietly through this zone are the transparent amphipods. Their exoskeletons let light slip straight through, making them close to invisible from almost any angle. They are textbook survivors of silhouette-based hunting, not by color, but by giving predators nothing to see. These creatures are strange and delicate, but this is still not the deepest layer the ocean has to offer. Down below, the rules become even stranger. Below the mid-levels, the ocean stops resembling anything familiar. Past 4,000 meters, and especially near the trenches at around 11,000, we enter the abyss and the Hadal Zone, regions of absolute darkness. Here, there is no natural light at all. Pressure rises to levels that would crush most life instantly, so bodies become gelatinous, soft, and flexible. Not because of fragility, but because rigidity simply can't survive. Movement slows, metabolism slows, and food is scarce. Everything alive here grows in ways shaped more by energy conservation than by speed or strength. It feels less like biology we know, and more like something shaped for another world entirely. When we look closer at why transparency keeps appearing in the deep ocean, there's a reason that goes beyond camouflage. It comes down to energy building, and maintaining pigment takes energy. Keeping dense tissues and complex structures takes energy. And food down here is rare enough that every calorie matters. So instead of investing in thick, colorful bodies, deep-sea organisms follow a simpler path. Their bodies become soft, gelatinous, and mostly unpigmented, not because that looks alien to us, but because it's cheaper for them to live that way. Evolution doesn't favor complexity here. It favors anything that keeps energy costs low. And since every layer of the deep faces the same limitations, evolution keeps arriving at transparency repeatedly, as if it's the most practical solution available in this environment. What makes transparency even more interesting is that it doesn't come from a single shared ancestor. Squid, octopus, larvae, certain jellies, deep-sea eels, they all develop transparent bodies, but none of them inherited it from a common transparent species. They arrived at the same solution independently. That means transparency isn't a rare trait passed down through one evolutionary line. It's something the deep ocean keeps shaping on its own again and again, in different animals facing the same environmental pressures. This is convergent evolution in action. Different creatures with different histories, all pushed toward the same answer by the same conditions in the deep. Some of the most remarkable transparent creatures in the deep rarely show themselves for long. The glass octopus is a good example. Most of its body is nearly invisible, leaving only the optic nerves in the eyes distinct. We have footage of it, but it's rare and brief, and every encounter reminds us how little we understand about its life. Then there are the leptocephalus eel larvae. They're almost perfectly transparent and shaped like thin leaves, drifting across thousands of miles of open ocean. Their bodies are so simple and clear that they seem more like glass sheets than fish, and in many parts of the deep, salps drift in long, gelatinous chains. These colonies look like a slow-moving conveyor, each individual nearly invisible, all sharing the same quiet journey through the water. These creatures are strange, delicate, and unlike anything found near the surface, yet transparency remains one of their most effective ways to avoid being seen. For all the transparency we can study, there is even more that we can't. Many deep-sea species collapse or melt when brought to the surface, their bodies built for a pressure world we can't recreate here. Others have only been recorded once and never observed again, leaving us with just a few seconds of footage and more questions than answers. Cameras also fail in unexpected ways. Transparent bodies bend and refract light, slipping past sensors that are designed to capture solid shapes. It's possible that many species drift right past our equipment without leaving a trace. So if transparency already hides creatures we struggle to study, it makes you wonder what exists even deeper, beyond anything our tools have reached. And as we keep exploring, we may find forms of transparency even more extreme than what we know. Because the deeper the ocean, the stranger the rules become. Evolution doesn't just adapt to darkness, it shapes bodies in ways that challenge how we define life.